Hi everyone. Here's the last lesson, the last example from the combination package, and that's example 9. Notice that this example says solve. And we're familiar with these. It kind of looks like an algebraic factorial type of solving question, because it is. And what it means is at the very end, we're going to end up with n equal to something. So before we jump in, I want to point out a couple things. Just take a look if I was reading this question from left to right. 6 times the permutation of n choose 3 equals 120 times the combination of n choose 5. So we're taking our permutations and mixing them in with our combinations. So before we get into it, I want to just review over the permutation formula, which is n factorial over n minus r factorial. And I want to review over the combination formula, which is n factorial over r factorial n minus r factorial. Because we're going to have to use both of those rules. Okay, so let's start. Let's start with the left-hand side. 6, big huge bracket, and let's take a look at the permutation. N factorial over n minus r factorial. 120 on the right-hand side, big huge bracket, combination n factorial over r factorial n minus r factorial. So our first step is just me using the two formulas, perm formula, com formula. Now I'm going to expand and simplify my factorials. So on the left-hand side, n factorial over n minus 3 factorial we know is n minus 1, n minus 2, and then everything from n minus 3 on would be canceled. Excellent. 120. Now, let's clean this thing up just a little bit. N factorial is as clean as it can be. 5 factorial is 120, and n minus 5 factorial stays at that. So, can I just show you something? Let me get a red pen here. Underneath that 120 is a little 1, but I also see this 120. What if I pulled that out? And let me show you what I mean. 120 over 120, all multiplied by n factorial over n minus 5 factorial. So you're just moving things out. You're just moving this out in front so you can clean it up. And that cleans up beautifully. Let's take one more line. I know there's a lot of writing in this one, but I want it to be crystal clear for you. So 120 divided by 120 is 1. It's gone. Now I just have to clean up that factorial. N factorial over n minus 5 factorial is n minus 1, n minus 2, n minus 3, n minus 4, and then everything from n minus 5 would cancel. So when I look at this, I'm absolutely not going to expand the left-hand side because it would result in a cubic. And I'm definitely not going to expand the right-hand side because it would result in a quintic. So I'm going to look on the left and look on the right, and I'm going to look for matchy-matchy. Got one. Got another matchy-matchy. Got a third matchy-matchy. So that leaves me with 6 on the left-hand side, n minus 4 times n minus 5 on the right-hand side. Let's expand using FOIL. let's clean up, moving everything to the right-hand side. And let's clean up collecting like terms. So I'm left with a quadratic of two possible numbers that multiply to 14 and add or subtract to -9. Uh-oh, boo-boo, boo-boo, just caught myself. Hold on, guys. I just realized. So bear with me for a second. This should have been n-3 and n-4. So when I expanded, it should have been -3n -4 plus 12. And when I brought the 6 over, -3n -4n plus 12 minus 6, -7n plus 6. So I'm asking myself, what two numbers multiply to 6 and add to -7? Sorry about that, guys. Are we clear then? I just made a boo-boo. Should have been -3 and -4. Expanded, cleaned up, and now factored. Now that will result in an n equal to 6 and an n equal to 1. And again, the issue is this a question where I have two solutions, or is this a question where I have one? And I've had a few people contact me about this. So let me just show you crystal clear how you're deciding whether something is inadmissible. If I take a look at this 6 and I substitute it in, right in here, 6 factorial, 6 minus 3 is 3 factorial, 6 factorial, 6 minus 5 is 1 factorial. All results in positive factorials, no negatives, no fractions, I'm good to go. If I take this 1 factorial works fine here, but we've got a problem. 1 minus 3 gives me a negative factorial. So this one right here is my inadmiss. Okay? So this is a fantastic test question because it combines our skills using the permutation formula for algebraic factorials and our skills of using the combination formula with algebraic factorials. Good luck with tonight's homework. I've included full solutions. Thank you.